Guys, this is going to be a review of writing reactions that we did way back in the winter of this year, so like second quarter-ish. Okay, so it'll be pretty quick. I'm just going to cover some examples of how to write reactions again, remember, because it'll be important for this next chapter. There will be no homework for this, but it's for your own review. So when we first did writing reactions, okay, we talked about single and double replacements, which is what we'll primarily deal with right now. Okay, so when we're doing combustion, won't be dealing with those acids or those bases or anything like that. Just single and double. Remember, we had to use these guys, the solubility rules. And we use these, remember, to determine if we had a reaction occurring. Because remember, right, we talked about a phase of being something aqueous. Okay, if something was aqueous, that means it was dissolved in the water, it was dissolved in solution. There was no solid forming. Okay, so if I had two products, remember, let's say I had one product being an aqueous solution and the other one being in an aqueous phase, there was no reaction here, NR. And we determined that by remember, our solubility rules, where if something was soluble, okay, remember that was when it was an aqueous solution. But if it was insoluble, that means we actually formed a solid, we formed a precipitate. Okay? So that was when we actually had one of them being a solid. So let's say if one thing is a solid and the other is an aqueous, okay, there was a reaction happening now here. And we used these rules to determine it, remember, right? From only the products, not the reactants. Okay, the reactants will always be aqueous things, but the products are what you are looking at always. So let's kind of review again these. Where did my mouse go? There we go. We'll do a couple examples, really, only. So let's look at our first one. Okay. Let's say we have potassium iodide, which is an aqueous, and now it's important that you guys write the phases for everything, plus PbNO3, so lead nitrate in aqueous solution. So remember, this is a double replacement reaction because we have two ionic things happening. So remember, things of the same charge switch spots. So now these two, remember the potassium and the lead will switch spots, creating, if lead will now go with iodide. So I'll have lead iodide, PbI2, in some phase, plus potassium nitrate, KNO3. Then we said to balance it, remember, right? You got two iodides over here, one over here. Put a 2 there. Okay. Two nitrates over here, one over there, two potassiums now, one lead, I'm good. So remember, you have to remember how to balance these reactions and how to write formulas. Okay, if you know how to write formulas, go back and look at your notes or ask me for help. Okay. So now remember, we looked at these two and determined what kind of state they were in. Okay. If you look at potassium nitrate, all nitrates are always going to be soluble, which meant this was an aqueous thing. Okay. But when we look at lead iodide, okay, in this case, if you look back at your iodides, okay, iodides I's were soluble, okay, but unless they're paired with some metals, which one of them was lead, which makes this a solid. So this was a reaction happening now. All right, let's look at another one. Let's say now we are doing potassium iodide again, let's say. Plus this time, let's do sodium chloride, NaCl. Also remember, guys, if I give you the names of these, so if I say potassium iodide, and sodium chloride, you should be able to write formulas again. Okay, so you have to go from the words to the actual formula again, right? Told you everything comes back. But again, we have a double replacement here going on. Okay. So let's say these two switch spots. Okay, so if those two switched again, that means we'll have sodium iodide plus potassium, where's it, chloride. Okay, oh, I wrote this one, no, one's fine, yep. 1 minus, 1 minus, and we're good. So then everything is balanced. Now we have to look at the phases of these guys, okay? And we'll look at our solubility rules. If we look at chlorides, chlorides are aqueous or soluble in solution unless they're paired with silver, mercury, or lead, which is not one of these. So this is aqueous. And iodides that we just talked about were in that same family. And sodium was not one of the exceptions. So this is aqueous also, which means there is no reaction happening here. All right, let's do one more with actual words written, and then that'll basically be it. So let's say I have a solution of potassium carbonate. Yeah, I don't know why I think I spelled that wrong. Potassium carbonate is mixed with nickel 2 chloride. Right, so I want to figure out what the resulting reaction is if one happens. All right, so let's write our formulas here. Potassium, we know that's our K. Carbonate, remember that was one of your polyatomic ions. You had to look back, which was CO3. Remember, potassium is a 1 plus thing. Carbonate was 2 minus, so I needed 2 potassiums to balance it out. And like I said, all your reactions are going to be in aqueous. Plus nickel, Ni. Remember, this 2 always meant the charge, not how many. So the charge is 2 plus. And then chloride is Cl, which remember is a 1 minus. So I need 2 chlorines to balance out the 2 plus and nickel. And this is also an aqueous because I said solutions. Now we can finish our formula. So we know now that potassium and nickel will switch spots. Okay. So now I have nickel still 2 plus with CO3, which they're both 2s, so it's just a 1-to-1 ratio. Plus, now potassium with gold chloride, and same thing, it'll just be KCl because potassium is 1 plus, chloride is 1 minus. Now we're going to look at our states in a second after we balance it, because remember you have to have a balanced reaction. 2 potassiums over here, 1 over here. We'll put a 2 here, which will make 2 chlorines, 1 nickel, 1 carbonate, 1 carbonate. I'm done. Now let's look at our solubility rules. Let's look at KCl again. Remember we talked about chlorides last one. All chlorides are soluble except with 3 metals, which potassium is not one of them. So this will be aqueous. While carbonates are insoluble, okay, unless they're paired with some other positive ions, but nickel is not one of them. So this carbonate molecule will be insoluble. So I will have a solid, I will have a reaction here. All right, but that's just a quick rundown of writing reactions again, okay? So there's no homework, it's just review for you guys, all right? Because we're going to be doing this type of, we're going to expand upon these reactions in the next chapter, all right? If you have any questions, like always, let me know.